Okay, people, let's start. Any questions from the yesterday's lecture? Yes?
I tried the minus O3 in the compiler switches step. There was no 24. My constant value was 24.
O3?
Yeah.
Yeah.
There was align command to try the now.
So what were you trying? Just remind us.
I was looking if there was multiple instances of a constant value in the assembly.
Yeah.
When there was no minus O3. There was multiple instances. When there was minus O3.
Yeah.
And when there was no 24 in the whole assembly.
Did you see the constant itself in the code, the assembly code? The constant itself, did you see it?
No.
No, it is fully optimized. Maybe whatever it was doing it during the compile time. Anyways, I mean, when you try to analyze your assembly code, don't use the optimization flags because you don't know what compiler is doing. Compilers are much smarter nowadays. They are smarter than us because they know the language, they know the processor itself, what kind of code it produces. I mean, most especially C and C++ compilers, they are very, very advanced. Okay, good. So we ask our classmate to test what happens to the constant, named constants. Do we see them in some memory location or do we see them in multiple instances in the code? He says that when you turn the optimization on, the constants somehow go away. Depending on how you use the constant, it might decide that you don't need it anyway, or I am going to include this constant calculation in the calculation itself, and etc. Remember the example I showed you? There was a loop that adds all the numbers from 1 to 100. It doesn't run any code to calculate it, okay? It doesn't produce any code to calculate it. During the compile time, it calculates it and it just directly plugs it in. Okay, good. Any other questions? And somebody was going to take the address of a constant, named constant. What happened?
I took it and it gave me. Maybe it's a compiled. I don't know.
So did you try to look at the assembly code?
I look at it, but I can see the variable name.
You can see the variable name. So I mean, no, this is what I'm trying to say. The compiler might produce two different code, okay? If you take the address of a named constant, then it's going to make memory location for it. If you don't take it, then it doesn't need a memory location. So that's what I was asking. So these kind of experiments are all nice. But the thing is, I mean, compilers are nice to learn a language, but whatever the compiler is doing doesn't mean that it is the correct thing for the language, okay? Most of the time, compilers play lots of tricks. They implement it in an easy way. Sometimes they say that I cannot implement the standard, so I am going to ignore it, or I will be wrong in this case, and etc. And sometimes the standard doesn't say anything about. Sometimes the standard doesn't say anything about that rule, okay? And the compiler chooses the easy way. That doesn't make the compiler right, okay? It is just an arbitrary decision, okay? And you know this problem, right? When you say integer I and j, etc., then people do this, then they print out plus I, okay? Most of the time, they get the value of what on the screen? Most of the time, they get the value of what? The initial value of I, we don't know. But most of the time, it turns out to be 0 by coincidence, okay? And when you do this plus I, it's going to give you 1, okay? And you run this 100 times on the same machine with the same compiler. Most of the time, we are going to get 1, but that doesn't make it right, okay? That doesn't make it right. You are violating one of the rules of C++. you are using uninitialized variable. What I am saying is that whatever you get from the compiler doesn't mean that it is the correct thing, okay? So you need to be careful about that. Good. So we talked about casting, type casting. If you are going to cast a variable to another one, we don't use the C way of doing it, like this one. We use the C++ ways of typecasting from one variable type to another variable type, okay? Later, this is going to be important. Because in C++ or in any object-oriented programming language, we are going to make our own types. Like integer is a type, double is a type, right? We are going to make our own types, and we will have to write these kind of operators to typecast from our type to doubles, or doubles from doubles to our type, and etc. Okay, we will have stuff like, for example, you know the rational numbers, right? Integers are nice, floats are nice, but how about rational numbers like this? I like to write a class for a rational number. For example, I am going to say I have a rational number R1, and its initial values will be 3 and 7, 3 over 7, and I have a double D1, and its initial value is going to be, by the way, in C++ you can initialize your variables this way, okay? So R1 is a rational, D1 is a double, and if I have the correct operators implemented, overloaded, I can do stuff like this. D1 gets the value of R1 plus 7.5. Okay, so in this case, I can do the arithmetic between a rational and a double, and I can do the assignment, that kind of stuff. And sometimes maybe I will have to typecast between a rational and a double. In that case, you have to implement two. In this case, your class needs to know how to add a double with a rational, how to assign a rational to a double, and how to cast a double to a rational or rational to a double. Who's going to do all of these? Of course, we are going to do this as the class designers. Okay, that's the kind of basic principle of the object-oriented programming languages. You design classes. Okay, classes means you need types, and you start using them. And those classes will be very reusable classes. Why? Because they will be very similar to doubles or integers. We have been using doubles and integers, and we love them, right? So the idea is design classes, they are as simple, as easy to use as doubles, okay? Your customers will not realize that they are complicated classes because they are so easy to use, because they are so well designed. That's what we are going to do. And in that case, as I said before, I mean, the reason why I'm talking about this static cast this much is not because we need to convert from integers to doubles. It is because we are going to use these operators to convert from our types to standard types, or from standard types to our types. Okay, already talked about it. There is a example here. This is an operator. Okay, operators are different from functions. Okay, when you say sum, let's say I have a very simple function, sum, it takes two integers, 1 and 7. It adds them and returns the result. So this function is going to return an 8. Okay, this is a function, but the regular plus operator that we use, it is doing exactly the same thing, but it's an operator. Operators are different from functions. Okay, in C, C++, we have both functions and operators. Okay, of course, we can write our own functions. In C++, we are going to have our own operators overloaded. Okay, we are going to say that the meaning of the plus is, from now on, Whatever I had before, but on top of it, I am going to have this one too. So this one is an operator too. Okay, this one is an operator too. By the way, you might say, why do we need operators? I mean, if we have the functions like that, why do I have to have the operators? Well, most of the time you don't. For example, let's look at this expression. A gets the value of B times 7. Well, I can write a function, assign. It's going to make an assignment to A. That's why I need to send the address of it. Okay. Then whatever I have B times 7, I am going to assign it to A. But how am I going to calculate B times 7? Then I should maybe multiplication function is going to take 2 parameters, right? So instead of the above statement, I can write the statement below. That is exactly the same thing if I implement assign and multiplication the correct way. But for some reason, humans prefer this notation. Okay, when you look at it, it is more readable, they say. Okay, that's why we like operators. That's why we like operators. Of course, I mean, that's not the only reason. It is not for syntactic purposes only. Size of is an operator. Okay, with the size of, you can say long double, right? You cannot write a function like size of. No function will take the variable name, right? Functions will take these kind of arguments. These are their parameters. You cannot send a function, you cannot write a function f that will take an int, right? You need to send a parameter, an integer. You cannot send a variable name. You cannot send a variable type. Okay, so no function is possible like that. But with the size of operator, this kind of stuff is possible. So they are a little bit more capable of doing stuff than the functions, but most of the time we will say that they are like functions. Okay. Shorthand operators are available: pre-increment, pre-decrement, post-increment operators. Okay. If you use these operators by themselves without any involvement with any expression, they are as simple as this. So when you say integer value plus plus, it is the same as add 1 to the integer value and assign the same value to integer value, or do it this way. I mean, if you use it just standalone statement, they are as simple as this. But sometimes we use them in expressions. Yes?
When we use functions, we are sending parameters, but the parameters are integer or double. What is the difference? We can send directly integer, but the parameter is integer.
You mean, are you talking about this?
Yes.
Well, I mean, you can send, look at this size of, okay? I can say size of 7.0, right? And I can call a function with 7.0, right?
Yeah.
Can you call a function with double variable name? Okay, that's what I'm saying. You can call size of with long double.
I understand this, but what changes?
Well, I mean, the operators are special language structures. They are different than functions. That's what I'm trying to say. When I say that, okay, instead of using this, we could have used this. That's true, but sometimes we need this kind of a mechanism in a language. By the way, this is resolved in compile time. During the compile time, the compiler knows the size of the long double, and it doesn't run anything during the runtime to calculate it. Okay, so the shorthand operators are there, and the meaning of these actually, post-increment operator, the book kind of talks it in a, I don't want to say wrong, but in a misleading way. The book say it in a different way, but the correct definition of post-increment is increments the variable but returns the unincremented value. As soon as you call this operator, okay, it increments the variable, but it returns an unincremented value. These are operators, and they have to take something and return something, right? Okay, so this one increments the whatever it takes as a parameter, but it returns the original value. Pre-increment, like the post-increment, it increments the variable, okay, but it returns the incremented new value. Okay, it incremented new value. Those are the definitions. So when I ask people what happens here when you say A gets the value of plus plus B plus C plus plus, let's say ABC and ABC are all integers. Okay, they say that, okay, the first thing done in this expression is first B will be incremented, then addition will be done, okay, then the assignment is going to be done, then finally C will be incremented. No, that's not true, okay. First B and C are incremented, okay, that's the first thing that's done. First B and C are incremented. This B plus B returns the incremented value. This one returns the original value, not the incremented value. Then the addition is done, then the assignment is done. So there are 1, 2, 3, 4 operators running here. These two will run first, then the plus, then the assignment operator. Which one is going to run first? Plus B or C plus, we don't know. Okay? We don't know which one is going to be run first, because they are not at the same level of execution path. Let's try maybe they showed you this before, but I like showing this expression trees a lot. Let me bring it in here, and let me make it a little bit larger. Oh, I didn't want to do that way, but maybe I can do it. Okay, good. So let's draw the expression tree. Are you going to ask a question?
Can you give an example of this expression with numbers?
Okay, integer A doesn't have to be initialized. B is 0, C is 0. So what is the value of A is going to be? You tell me.
1.
Yeah, why? Because this one is going to return. This one is going to. Okay, let's do this. What am I going to see on the screen?
1.
And C is going to be 1, 1, 1, right? All three of them, okay. So let's see the expression tree. Expression tree is this. It's a tree most of the time, binary tree. It looks like binary tree, but it is not. At the root of the node, I say assignment operator. On the left side, A will be here. Here is going to be plus, then plus operator is B, and plus operator is C. So when you traverse this expression tree, to be able to do this assignment, you need two values, left side and the right side. Left side is A, I know it. Right side is another operator. Then, as you see, this is another expression, okay? So I need to evaluate this. I need two values from left side and right side, both of them operators. Let's run them. This is plus B, this is C plus. Okay, they are different operators, but they are operators, and I run them, I get the results. This one, b will return 0. Okay, plus plus b is going to return 1. So let's write it. This is going to return 1. This is going to return 0, and plus is going to return 1, and assignment is going to return. What is the result of the assignment? I am assigning 1 to A, and it's going to return 1. This whole expression is going to return 1, but there are side effects of it. Plus plus and this plus plus, they are different, but they have side effects. The side effect is increment the value of B, increment the value of B, change the value of A. Okay? Yes?
We said that we don't know if B or C plus plus will be executed first.
Yeah.
So if B plus plus is executed first, B is incremented, then B is called.
No. Well, it says, well, this is an operator, right? This operator is like a function. I am an operator, I need a parameter, okay? I get the parameter, it is B. What I am going to do is, I am going to increment B, and I will return the incremented value. The other one says that I get a parameter, I am going to increment C, but before I incrementing C, I will take its original value and return it. Okay, so this one is kind of more expensive because it has to take the backup of C original value of it. This one doesn't take any backups. That's why most of the time we try to use plus plus I, plus plus B, J, etc. Because this is a little bit more efficient. It doesn't need any memory. This one has to take the backup of the original parameter. Okay. So what did I say? Okay. Remember what I said before? We can write functions instead of the operators. Okay, instead of the operators. Let's try to get this. Do I have enough space here? Maybe. Yeah. Well, okay. Let me take this, copy it again, take it down here. Did I do that? No. I did exactly the same thing. Yeah, okay, good. I like to write this using functions only. Okay, so maybe assign address of A. These are all integers. Then there is an add function, right? So pre-increment PI should take what? Address of B, right? Otherwise I cannot increment it. Address of B, right? Then our pre-increment and post-increment is going to be the same thing. Okay, maybe PRI, pre-increment, and P or post-increment, and address of well, you know what I mean, address of C, parentheses, parentheses, and parentheses, right? Okay, let's implement these 1, 2, 3 functions. Assignment. What should the assignment return? What kind of function assignment? As the first parameter is going to take what? A, B, C are all integers, okay? Assignment should take, the first parameter of assignment should take, we don't say it integer address, it should take integer, it should take an integer pointer, okay? Integer pointer, okay, let's say IP. Then the second part is going to be an integer, right? Integer value. So it is as simple as IP gets the value of V, but you didn't answer me. What should I return? Is this a void function? The answer is no, it is not a void function. It cannot be a void function. If it's a void function, then this doesn't work. right? What is this? What should I return?
Return the reference I.
What?
Return the reference I.
Returns what?
It should print a star I.
Why?
Because
Well, I mean, what should I write here?
point
What?
integer.
I should write pointer here. Tell me a C++ keyword, C keyword. We are writing a function. Okay. Return, and two things missing here and here.
Boolean true or false.
Who is talking? Yeah.
Boolean true or false.
Boolean. If it returns Boolean, how this would work?
Integer and read.
Yeah, it should return an integer. Okay, and how about this one? Whatever value I am having, I am going to return it. Okay? This is the assignment. And let's look at this PRI, pre-increment function. Okay? So the function pre-increment is going to take an integer pointer, right? And it will return what?
Integer.
An integer, right?
Increment integer.
Okay, so what am I gonna do now? It will take the integer pointer, IP. Since this is a pre-increment thing, let's increment this, whatever this IP points to. Okay, guess the value of IP plus 1, and then return.
IP value.
Yeah, return the referenced IP, right? This is a pre-increment. Okay, let's do the post-increment. Let me cheat a little bit, copy paste it. Okay, it's going to be a little bit different. Okay, so implementation is gone. This is post-increment. Again, it's going to take an integer pointer. So again, this is what I'm going to do. Immediately increment whatever this IP points to, right? But I need to return the original value of the referenced IP, right? But I mean, maybe I can say the reference IP minus 1, but I don't want to do two operators, okay? So I'm going to do this. Integer backup value, it is IP, right? The original dereferenced IP, and I will return the backup. Okay? Good? So, as you see, this post increment is a little bit more complicated because it is taking the backup of it. Also, it uses more memory. Okay, so, I mean, why am I talking about these? I'm trying to tell you that those integers, doubles, floats, whatever you are using, they are actually very complicated types, okay? You never realize that they are complicated, okay? You didn't think about the details of it. You have been using them happily as customers of those types, okay? In object-oriented programming languages, we try to write those kind of classes, those kind of types, and we have to deal with the complexities of whatever had to be inside those classes, but we will not reflect those complexities to our customers. Our customers will be happily using our classes like a rational. 2 adding to rational is just R1 plus R2, dividing two rationals, okay? Taking the inverse of a rational, converting from a rational to a double, etc., okay? They will not realize that that complicated things are happening under the hood of the engine, okay? They will be happily using our code. That's called software reusability, code reusability. And in object-oriented programming, that's one of our purposes, to write reusable classes. Okay, who's going to use them? Most of the time, again, myself as developer, I will be using them. But many times our customers, our paying customers, will be using our classes. So that's our first purpose. Write error-free, easy to use classes so that our customers can use them. Reusability is something very important in lives of the object, in lives of the software engineers, software professionals, because writing software is expensive. Most expensive part is the debugging and testing it. Okay, once you make sure that your software is free of bugs, mostly, okay, that's valuable software, and you like to use that software as much as possible. You don't want to rewrite it over again and again, okay, because it is written, it is tested, it is debugged. So let's use it. That's what will make your life a lot easier. Okay, that will make life a lot easier. You never had to write floating point division functions in your life, right? Because it is available. But you know how complicated it is, right? I mean, try to do this. I am going to try to write this. Write this div. It's going to return a double, and it will take two doubles, double D1 and double D2. Okay? Write this function without using the division operator. Okay? It's not going to be easy. You'll have to look up lots of stuff. You have to read lots of stuff. Okay? It's not easy to write it, but we have been using it like this. No problem. So it's a very nice operator. Complicated one, but it's nice to use, nice to write. Okay? It is nicer than this function, because with the function you have the parentheses and etc. That's what we are going to do with the object-oriented programming world. Try to write reusable software, and we are going to do that in terms of classes. You might say that, well, why don't we write reusable functions? That's a nice thing too. Yeah, that's true. But it turns out that the idea of the object-oriented programming is better. And we are going to see why writing classes instead of functions themselves is a better way of writing reusable code. Okay, I will be talking about this kind of stuff many times, philosophy of the object-oriented world. I'm going to skip this. Okay, we know how the post-increment and pre-increment works. I am sure they spend like 1 or 2 hours to tell you the way they work, but they work that way. By the way, when I said we don't know which one will be done first, plus plus p or c plus plus p or c plus plus, we don't know, because to evaluate this tree, I know that to be able to evaluate these assignment operators, I need these both sides. Okay, to evaluate this plus, I need these both sides. That's why I say that these two will be done before the plus. It has to. But before the plus, C++ or C doesn't say anything about this should be done first or that should be done first. Okay? Whichever one the compiler chooses, it does it first. That's why it's a bad idea to write this kind of code. Don't do this. Plus plus b plus minus minus b. Okay? It's a bad idea. We don't know if b will be incremented first or decremented first. Okay? We don't know. Because if you imagine, if you visualize the expression tree of this expression, the levels of these plus plus b and b minus minus b will be at the lowest level. Okay, it depends what kind of things they are going to return to you. That's why C is kind of dangerous in this way. Don't write this kind of code. Okay, It is compiler dependent, optimization flag dependent. Well, the C++ standard doesn't tell you the exact result of this one. Yeah.
Does order matter in this?
For this case, maybe it is not, but maybe it is not. It doesn't make any difference for this one. But how about this one? B guess the value of 2, integer b1. Okay. So I'm doing an assignment and incrementation at the same level. It depends if the incrementation is done first or the assignment is done first, right? Well, I mean, writing doesn't matter what I wrote, this one or the previous one. Those are both bad expressions. Don't write these kind of expressions. Again, I mean, write this one and compiler will give you an answer. That doesn't mean that that's the correct answer. Compiler has to give you an answer. Okay.
Can I ask another question? Say no difference if alone in states means identical result. It says things like.
Yeah, in the previous one.
Does it matter? For example, return plus variable name or variable name plus. I think it should differ from each other.
I don't understand. You are not asking a question about this one, right?
I'm asking a question about text and slide. If you zoom out, it's a return.
No, this one. Yeah, it's.
No. One slide later. Yes. No difference
If stand alone, yeah. Yeah, well, I mean, this one and this one is the same thing, identical results. Results are the same, but as you know, this pre-increment is more efficient because it doesn't take any backups, right? The results are the same, but in terms of efficiency, this is more efficient. This has to take a backup of it. But the compilers are smart enough to increment this value by 1 without taking a backup if you are doing it in a standalone way. But that's going to be different if we write our classes, because when we write our classes, we will have to overload this operator and this operator for our class. So what is, let's say R1 is a rational number, right? I like to increment it by 1 that way, or I like to increment it this way. Okay, we will have to implement those, and one of them has to take the backup of the rational. Okay, good. Console input output. Well, we talked about it actually. To be able to use these global variables, global objects, C in, C out, C error. Okay, this is standard. By default, it is connected to the standard output. By default, it is connected to the standard input. And this is the standard error stream. 3 streams, and you can play with them the way you want. Standard input is usually our keyboard. This is the screen. Usually this is the screen too. Usually standard error, character error stream, okay, and standard C out. They are all connected to the same destination, which is the screen, but you can change them if you like by using the mechanisms of the operating system, okay? And it depends on what kind of operating system you are using. For example, I think, what was the name of the test? Was it test? Yeah. So I can redirect it to s.txt. So whatever this test is sending the standard output, now will be redirected to s.txt. So I don't see anything because everything is going to s.txt. So I changed that default behavior of standard output connected to the screen. Now it is connected to this s.txt, but it is still expecting something from me, a number from the standard input, which is the keyboard. I send it, so it is all done. Let's see what s.txt has in it. See, it is this. Again, it depends on what kind of operating system you are using. In Unix, we do it this way. Windows does it in different ways, and but I can have access to all those standard input, standard output, and standard error streams. Okay, this stream insertion operator, they overloaded it in C++. Remember, in C we had these. Those are binary shift operators, left shift, right shift, right? They overloaded these, and by default, okay, by default, they are connected to the standard input and output. We told about it. The stream insertion operator is overloaded for all types of primitive types, like the doubles and integers and the strings and the characters and etc. And they are smart enough to know what kind of thing they are printing. It knows that number of games is an integer. It knows that this is a string literal. Whatever you put it in there, it will print it nicely. Remember our rational class? If you overload that stream insertion operator, this one will work nicely too. But by default doesn't work well. And you need to overload it. You need to tell the compiler that you should print a rational this way, whatever the way you prefer. Okay, like the assignment statement, remember this, I could do this, right? A gets the value of B, gets the value of C, gets the value of 2. Okay, I can do the same thing with the stream insertion operator. Okay, print R1, then print number of games, then games played, etc. So I could say, after the R1, I like you to print an integer 1. Okay, it will work. So that's called cascading. Multiple values in one count. Okay, so you overload your stream insertion operators that way so that cascading still works. Okay, cascading still works. We use our new lines, you know that. There is a separate, I don't want to say, well, cout is not part of C++ programming language, right? Printf is not part of the standard C language. Printf is part of the standard library, right? It is part of the standard library. If you, where is my, okay, open it here. How can I, Explorer? Yeah, let me open this place with an Explorer and let me try to open this with a, can I open this with a nice, yeah, okay. See my C++ keywords. Can I make this bit bigger? Yeah, bigger, yeah. My C++ keywords are, okay, using namespace, int. These are bold keywords. These are C++ keywords. If, else, return. Those are all C++ keywords. Main is not a C++ keyword. Cout is not a C++ keyword. Okay, cout, cin, cerr. Okay, those are all defined in the standard library. Those are meaningful only if you include this header file. Okay, if you include that header file. Like printf. Printf is not part of the C language. It is meaningful only if you include the proper header file and link your object file with the proper libraries. Okay. Like that one, this end of line is defined inside this IO stream header file. Okay, it's like cout. It is defined in there. Basically, it is just \n. Instead of writing hello world \n, you would write hello world and end of line. Same result as before. It depends on which one prefer. The C people prefer this way. C++, some of them they say we should do it this way. Okay, good. Any questions so far? Where is the attendance? Attendance? You are still signing it? Did I say that I take the photographs of the? Yeah. Okay. Yeah.
Can we do formatting in CL?
It is coming. Yes, we can, but you will be sorry you asked that question. Difficult to format stuff. But I mean, nobody uses printf CLC in any way in the real life. I mean, these are for showing you stuff because, as I said, most of you will be either doing embedded stuff. In that case, there are no screens. Or you will be using GUI stuff. In that case, there is no terminal. Okay. C++ standard library defines a new type, string. What did I say? I said that we are going to define our new types. They will be reusable. They will be nice, and etc. They did that already for the strings. We like our character arrays a lot in C. Remember the character arrays? Those null terminated character arrays. We call them strings. But C++ says that I will have my own string class. And its name, as expected, is going to be string. To be able to use it, just include this string header. And now you are going to be using my string class the way you want. How do I do it? I would do it this way. String S1, okay, and S2. The initial value of S2 is going to be, let's say, hello. Okay? I have now two strings, S1 and S2. S1 doesn't have anything in it. It is just a null string. It doesn't have anything. It is initialized. Don't take it as uninitialized. It is initialized, but it doesn't have anything in it. And the things that you expect to work with string is going to work now. I can say S1 gets the value of S2. Surprise, it works. In C, what did we do to copy the contents of one string to another? We use strcpy, right? Remember that function? String copy. Okay, that's what we did. It takes two character pointers and it copies the second one to the first one, right? String copy. Or I can do this kind of stuff. If S1 is the same as S2, then print S1. Okay? So they overloaded this is equal to operator 2. They overloaded the assignment operator is equal to operator. They overloaded less than operator, greater than all the comparison operators. They overloaded not equal to operator. Even they overloaded this, S1 plus assignment S2. Okay? This is what? This is similar to, yeah, what is the function? strcat, right? It is like strcat, right? I can do that. I can do stuff like S3 gets the value of S1 plus S2. Okay? So it is not, as I said before, this is a very reusable class string. And it is implemented by the standard library, and we are free to use it as we like. It is much easier to use than the C string structures, null terminated strings, and etc. I don't care. I mean, doing this is very difficult actually. This is better than strcat, right? Because what did I say? S1 doesn't contain anything. This one will dynamically make the space for the S1 large so that this one can fit in. Okay? That will do that too. Can I have it? I don't have that. That pen does not belong to me. I don't. Let me read a few names first. Kenan Eren Ayılmaz burada mı? Kenan. Burak Demirkaya. Öner burada mı? Öner Hacet. Yüksek lisanslardan okumayayım. Onlar burada olmazlarsa çok şey oluyor ya. Enes Akar. Okay. Somebody had a question? Yeah.
Can I add an integer or different type of string?
Can I add S1? Okay. S1 gets the value of S2 plus 1. Can I do that? What do you expect out of this? Well, if you don't know, if it is not meaningful, then don't do this, okay? And I am not sure if it is available or what?
Is there any way to add the integer?
Well, I mean, if you overload, if you give a new meaning to this plus operator, saying that I am overloading this plus operator so that it's going to take two parameters. One is a string, the other was an integer. And it will do this, and it will return that. Okay, you can do that, yeah. So you can extend other people's classes, if you like. Okay? And see, a string is a class that belongs to the standard template library, standard library. But if you like, you can. But usually the idea is operator overloading is something nice, but don't abuse it. Okay? Don't try to do stuff that will confuse other people.
So you don't need to stringify integer literal.
You don't what?
You don't need to stringify integer literal, like one to string one.
Yeah, well, I mean, that would be the meaning of it, like in Java. Well, I asked him on purpose because, I mean, what do you expect out of it? This one might work or may not work. I mean, it depends on if there is a default typecast operator that casts an integer to a string, then this will work.
Static cast string works in this case.
I don't know. If it is available, then this will work. Okay. So this is a string type. There are many useful classes like this defined inside the standard library. The other one is, do I have it at the end of this chapter? Do I have it at the end of this chapter? I hope I have it. No. Maybe, well, the other one is a vector. I am going to talk about it anyway. Vectors are like arrays, okay? Remember when you say, I have an integer array of size 10, okay? And I am going to initialize it with numbers 1, 2, etc. That's an integer array, right? And what do you do with the integer arrays? We do lots of useful stuff. We do, for example, we do sorting with the arrays, right? Because I have the index or the access and etc. But arrays had some difficult way of using them in them. For example, it is very difficult to resize an array. Well, I don't want to make this 10 anymore. I need to store more space in this array. C says, well, no, you don't. In that case, you need to use dynamic memory and etc. Vectors are kind of arrays. They are generalized versions of the arrays. You could say, I have an integer vector, like an integer array. Its name is AR, okay? And initially, it is empty, okay? Now, I like to push back. I like to put an integer in it. This array, this vector, is automatically resized. It can hold an integer in it right now, okay? And you can continue doing this. I from 0 to I less than, let's say, 10, plus I, and AR push back I times 10. So this loop will run 10 times, and every time my AR will be resized to a new size, and this new number, I times 10, whatever it is, will be inserted at the back of the array. Or maybe I shouldn't say array, it is a vector, right? So doing this kind of stuff is very easy. And the other nice thing is, I can say, okay, auto AR to AR, okay? Some people were asking the usefulness of auto. Did you see it? If I didn't write this auto, I had to write this vector into the whole thing. Okay, so AR2 is another vector of integers, and an initial value is AR. Okay, I can do this kind of initialization or assignment and that kind of stuff, or I can send this AR2 to a function like that. Okay, these are all nice stuff. So they are as nice as arrays, but on top of it, you don't have to deal with the resizing of the arrays, the assignment of it, sending it to a function, returning from a function, and etc. Okay, and the nice thing is, this is a vector of integers, right? I can have vector of rationals if I have a rational class. I didn't write the rational class yet, but I'm just giving you an example, okay? I can do that too. And of course, cout AR7 plus AR2 square brackets 5. These are all possible. Index access of the array. Okay, and if you like to decrease the size of the array a little bit, you will say AR dot pop back. Okay, it will remove the last element of the array, the vector. Okay, so again, this is another class that is defined inside the standard template library. And instead of arrays, we are using vectors right now. What other stuff do we have inside the vectors? I am way over time right now. How am I gonna open this Chrome now? Yeah, okay. Go to Chrome and C++ vectors. Yeah, this is the definition of the vector class, and these are some of the stuff that are defined on it. This operator that, yeah, push back, pop back, remember those two? I used 2 of them. You can use many other stuff like insert and delete. Okay, with the insert, you can insert many elements. Insert between this element and this element this much. Erase it, swap it, clear it, etc. And this operator, square bracket, is defined. You can ask the size of an array. That's one of the limitations of the C. Remember, what is your size? How many elements do you keep in you? AR.size will give you that.
Doesn't size of work with vector?
Does it what?
Size of the operator don't work with vector.
Well, I mean, size of will give you the size of the type vector, okay? Not your object. I mean, size of vector rational is different than size of AR. Okay? So we don't use it in here. Okay, let me take some break first because I am out of time right now. After the break, I will take your questions about these classes. başında bir sorsan.
Hocam imza atabilir miyiz?
Ne zaman geldin? Ne zaman geldin?
Dersin
20 dakika sonra.
Zamanında gelin arkadaşlar yani.
tamam hocam.
Öğretmenlerin nasıl çalıştığını
Bir dakika, ondan önce burada bir soru var.
Senin numaran kaç? 200 de başlıyor değil mi?
Evet. Sen kendin at, ben bulurum.
Pointer'ı increment mi edebiliyorsun? Pointer'ın varsa tabii arttırabilirsin ama onun manasının ne olduğunu dikkat etmen lazım. O array'lerle falan olabilir ancak o. Yapabilirsin. Eski yerini göstermen farklı bir yeri gösterir.
Peki string'de yapamıyorum.
Masada hepsi.
Ha, string'de mi? String'in içerisinde ne oluyor ne bitiyor karışmaman lazım. Yani ne dedik biz? Biz yani string çok güzel bir
Mehmet Mahir bu
ben
besmele
onu kullanıyorum ama içini merak etmemen lazım. Yani nasıl diyelim böyle operatör nasıl çalışıyor diye hiç bakmadık, içine karıştırmadık. String de içine karıştırmayacaksın. String içerisinde pointer mi kullanıyor, başka bir şey mi kullanıyor, yeni bir teknoloji mi kullanıyor, müşteri olarak seni ilgilendiren.
Numarandan baksana.
Onu
Numaran kaç?
string'i kendimiz implement edeceğiz.
232 numaram sana. Ama ismim de onu göremem ben.
Kanka bir sayfa eksik burada.
Eksik mi? Yok, bakmamışız.
Ama arkada buraya koy.
Bak burada.
Koskocaman chapter var ya, bakmadın mı kitaba? Operator overloading diye chapter var.
Bu şeyi yani görecek miyiz? Mesela öncelik sırası yok dediniz ya tam olarak. Compile zamanında bir şey var.
Öncelik sırası değişmeyecek ki.
Ya mesela fonksiyona göre yazdığımız
Geldiği zaman görürsün, tamam mı? O zaman onların hepsini atacağız. Onların hepsi sorduğun sorular sorular. Neyin üzerinde 15-20 dakika konuşmam gerekiyor.
Düzlükte burada kalsın.
Arkadaşlar şu camı sonuna kadar açabilir miyiz ya? Diğer camları da açalım da ders arasında.
Ahmet Hoca bilgisayarlarla ne yapıyor biliyor musunuz?
Ya kişi sayısı fazla. Zeki falan orada çok work yapıyor. Cümle derslerinde böyle
Ha.
siliyorum yani.
O tarafta.
O yüzden benim bir şey var.
Ceyhun vardı. Aybars şey başlamış. İsimleri.
Hepsi soyadlar.
Sarı sakallı değil mi? Tamam tamam. Ah hoca.
Alfa. Tepe'de diyebilirim alfa. Grup var. Mesela genel anlamda mezun açısından. Birine bir tane şey getirdi. Önder Şubat dedi. Böyle zehir gibi bir adam. Ben böyle asistan diyor ama bayağı sabırlı bir adam. Çok öğrenci almıyor gerçekten. Yani. Ya biliyor nereden geldiğini bilmiyoruz. Öyle bir şey olamaz. 90 kişi sınav veriyor. Kalan 66 kişi nasıl geliyor arkadaş? Kalifiye mi yok bir de? Nerede yok zaten? Sen aklına olmadık şeyleri getiriyor. Pozitif.
Biz Post-Increment okulu bırakıp genelde
2017'siyim arkadaşlar.
ben geldim mesela. DGS'ye 10 kişi aldım bu sene.
DGS'de 10 kişi aldım.
Yabancı öğrenciler.
DGS sosyal sınavla geliyor. Normal bir şey. Ve hadi etti 100 kişi. 56 kişi nereden geliyor? Şimdi anlamıyorum. Nerede ders
Sana hiç sormadı da sen niye derse gidiyorsun diye. Hadi döndü oraya, gözüne çarpmasın belki. Ama sen hiç dersine girmedin onu tanımıyorsun. Ha o zaman diğerleri
elektroniğin binası güzel oldu gibi ama.
Aynen kanka. Baksana arkasında şey. Mustafa'sı yok. Oğlum kılıf gibi lan. Kılıf mu acaba? Şuralara baksana.
o makineyi biz alamayız valla. Ona bir şey olsa. 10 sene çalışsam.
Oraya adalar mı? Oraya adalar mı?
Camları açmamıştır diye.
Şu aşağı açılmıyor herhalde bu. Sen beni biraz yanlışlıkla yazıyorsun.
Ne yaparsan yap, hep aynı hareketi yap. Okay. So these are the let's start. This is the reference page from c++.com for the string class. Okay. There are many things defined for string. Of course, one of them is the assignment operator. I am going to skip the iterator. Iterators are kind of special pointers for the standard template library stuff. You may ask the size of a string, or length is the same thing, and the capacity of it. You can clear the string, and operator index works, of course, plus assignment works, append works, pushback works, and etc. Okay, so many things are possible with the string. So see, the way we use functions in C++ is a little bit different, right? I can say, what did I do right a few minutes ago about this one? Yeah, okay. So I call this function pushback on this variable AR. AR.pushback. It's like accessing a data member of a struct, okay? Instead of accessing the data member, you are calling a function member of a class, okay? So these functions are defined inside a class, and you are free to call them as you are allowed to. And they are nicely placed into these kind of documentation structures. If you have a class like string, what kind of functions can I call on this class? It is all listed. Some of them we already did, some of them you don't know, okay? You can always look at them, you can click on them, and you will see examples of it. For example, just click on it and see there is a, okay? There is an example here, and in c++.com is a nice website. You can edit and run it. I am clicking on it. So it is a runnable program actually. String str and test string, and from 0 to length of the string, print out all the characters one by one, and it looks like you can specify, yeah, I am going to do it with C++11, and optimization none, and compile it. Does it compile now? How do I, yeah, run. It is compiling. Yeah, and it ran already. It says test string. because I am printing them one by one. If I do this, yeah, backslash, I don't know how to do backslash n. Where is backslash? Backslash is this, yeah, I found it. Backslash n, let me get rid of it. And now run. It's going to, as you see, it printed each character on a different line. So the index operator works that way, and length function works that way. Instead of doing the index operator, you could use this function at I. It is exactly the same thing. There is a little bit difference, but it is the same thing. Okay. So what did I say? Most of the time you can write a function instead of an operator. Here the function at I. Okay. So use the C++ com to look at these kind of classes, what kind of classes we have. Okay. String is here. What kind of other classes we have? Interesting classes. Yeah, there is a complex number available. See, complex number library, and you can do many stuff with it. Overload of the stuff. Let me see if, okay, there is no example constructor. Okay, here it is. Okay, it's a complex number, but it uses double numbers to represent the imaginary and the real part, first and second. Okay, and it just prints it. This one is overloaded, and there are many things defined on this complex number, and examples are already there. Okay, just check this out. Okay, just check this c++.com out.
Complex is a class?
Complex is a class, right? I don't know which version of C++ yeah, C++ 98 and C++ 11. I guess they changed a number of things from C++ 98 to C++ 11. You can check this stuff, algorithm inside the algorithm, functional iterators. Interesting. Do we have rationals? I don't think that we have the rationals. The regular expressions, for those of you who know about regular expressions. Anyway, I'm not going to talk about them. This is interesting, but it takes lots of time to talk about them. Okay, let's go back to our example. Okay, string plus operator works on the strings. Stream insertion and extraction operator work on the string. It's a very nicely designed class, and we are going to use it. Let's look at this simple program again. To be able to use C in, C out, stream insertion, extraction, I am including IO stream. Then I am including this string header. Okay. In C, we had a string class header, right? In C, we had a string header. In C++, most of the headers that we use for C, they are available for us. For example, there was a math.h header, right? To be able to use it, you put a C in front of it and you include it. Include C math, okay? Then all those math functions are available for you. If you like to use the C type of strings, then you need to include C string. Okay? Whatever you had in C, if you like to use it in C++, you need to include the header. Then you put a C character at the beginning and include that one. Okay? Good. So this one includes the string. This one is for C++ string from the standard library. We are not talking about line number 4 right now. I have a string. I have two integers. C integers are blue. Okay, because they are keywords. String is not a part of the language, but it's part of the standard library. I have the dog name actual age and the human age, I ask the user to give me the age of the dog, okay? The theory says that the dogs age much faster than humans, 7 times faster. So if you like to compare the age of a human with a dog, you multiply the dog's age with 7, okay? Humans live like 70 years on the average, and dogs live like 10 years on the average. There is a 7 times difference, okay? So I asked the user to give me the dog's age, and I calculated the corresponding human age by multiplying it with 7, and I asked the dog's name, and I printed this, okay? Dog's age is approximately equivalent to human age, year-old human, okay? Again, very simple program. How many years old is your dog? 5. What is the dog's name? Rex. Rex's age is approximately equivalent to 35-year-old human. Okay. So again, just a simple program to demonstrate how to use strings. Well, for the strings, I didn't do much actually. All I did was stream extraction and stream insertion. By the way, I hope you realize it. They look the same, but the meaning of this insertion and the meaning of this insertion and the meaning of this insertion are all different. This one works for the C++ string. This one works for the integers, and this one works for the character arrays, right? Like this. But for us, we just keep using it. It's like 2.5 plus 7 plus maybe I should have 9 plus 2 plus, yeah. The meaning of this plus is different than the meaning of this plus, right? This is integer addition, this is double addition, this is double addition, okay? It is similar to that. So, but their meanings are different. But when you write them in a straightforward way. It looks so natural. But under the hood, there are many things that are happening.
Can we assign it instead of cout, and assign string variable, assign all of these?
You mean you say that you are saying that instead of printing out to the standard output, let's make the, yeah, sure, yeah, there is a way of doing it. Well, I mean, of course, you can add 2 strings, S1 and S2, okay, and assign it to a third string. You keep doing this, okay, and it will work. We will talk about them later. I mean, dealing with the string and those kind of, instead of doing the, I mean, can I do as printf kind of stuff? Yes. Later we are going to see it. Yeah.
Can you show the calculation tree for this one?
This one? Well, no. Okay. Let me do it in another way. Okay. Cout 2 and ABC. Let's do this. Okay. It's called the expression tree, by the way. Well, I have 2 of them. The first one is this. The first one is, okay, you tell me what the first one is. I am going to, okay. What should I write to the left and right? Or maybe I should do, okay. Let me do, okay. Let me start myself. The first one is this, cout and 2, okay. So tell me, how am I going to continue?
Operation instead of 2, maybe.
What?
Insertion operation instead of 2.
You mean this? And then what? 2. Well, it needs another one. I have 3 things already, okay? You mean ABC here? Yes. What? ABC here and 2 here? But this one doesn't take 2 parameters. On the left side there is 2 and on the right side there is ABC. This one doesn't work now. It doesn't work. No, it's not it. This is correct. Cout 2. It's going to print a 2 on the screen first, then what? Where am I going to put this ABC? And it has to be a second. There has to be a second.
I think it, say, now I'm not in this.
Behaves.
I think it behaves differently for two.
Don't give me a philosophical answer. Just tell me what should I do.
Insertion under 2.
Under 2?
Yeah,
2 is not an operator. I cannot write anything under 2. How about this? And then A, B, C. When you are going to tell me, okay, maybe do it right. Okay. So you are going to tell me this, okay? To be able to do this, I have the right-hand side operand, but left-hand side is not ready. So let's do this. This one will do cout 2. It will print 2 on the screen, but this one will return what? Remember what it returns from yesterday? It returns cout, right? Then this one will do cout on the left, ABC on the right. Okay? So this is how it works. Okay? It is similar to actually, this is no different than, I don't know why you are confused. This is no different than 2 plus 5 plus 7, okay? Plus 2, 5, and then plus 7, right? 2 plus 5 will be done first, then 7 will be added later. We already know that. Well, you might say, in this case, we know which plus is going to be done first. Yes, that's true. Because 2 plus 5 is going to, expression 3 says so. How about this? How about this? Plus, times, and times. Plus is at the top, right? Then I have the multiplication, 2, 5, 7, 8. Which one will be done first? 2 times 5 or 7 times 8? The answer is, we don't know. Okay, because the expression 3, both ways are okay. Okay. Good. Why did you, who asked, you asked the question, why did you ask this question?
I was confused.
Okay, now you are more confused now. That's good, okay. I mean, yeah, that's true. If you don't get confused every lecture, then you are behind. You should get confused at every lecture. If something I'm telling you is too simple to talk about, then you are confused, okay? But they are simple, but as I said, it takes a little bit time to realize what is really happening. Sometimes you will go back and you will make the simplest mistake. When you realize that mistake, that you are confused about something, then things are on track. The thing is that if you are getting confused during the midterm exam and the final exam, that's too late. Okay? If you're going to get confused during the class or just after the class. Okay, good. So somebody had asked a question. When we say see out the price is the price, you are going to get this ugly output, $78, and instead of 50 cents, you get 50000. We don't like these kind of money formats. Okay, we need to format this so that it writes nicely 78.50, right? So we need to format it. In C, it was possible. It was just, we said that, okay, I need only a 1 digit after the decimal point, and I like you to place the whole number in a 3 character space. Okay, that was the meaning of it, right? Formatting of the printf. In C++, we do the formatting this way. We say that, remember cout, okay? Whatever I do with the cout is going to be fixed point printouts. So it's going to be 5.7 and etc. It's not going to be 5e minus 2, etc. Remember, what is this? 5e minus 2. It means 5 times 10 to the power 2, right? Scientific notation. I don't want the scientific notation. I want the fixed notation. With the fixed notation, always show me the point, the decimal point. The precision is going to be 2. So I give these 3 format statements before I see out anything. Then I print the stuff and it's going to give me this one. Well, you might say that I don't like this. I mean, it used to be with the printf way of doing things, it is much simpler, more understandable stuff. In C++, it is like this. You need to modify your stream. Stream takes stuff and prints it on the screen or standard output. Okay. You are modifying stream. You are saying that whatever I am printing from now on, they all, if they are floating point numbers, they will be fixed point, and I am going to show the point all the time. Precision is going to be 2 all the time. Okay. So what kind of flags, what kind of properties I can set, they are available in the documentation. Just check out the documentation of the cout. Check out the documentation of the streams. And there is a complete chapter about the streams and the formatting of the streams in the book. And I'm not going to cover that chapter, I think, because those are straightforward stuff. You can read it and you can learn it. Yeah.
What if I don't want to see any 0 after the point?
Then you set your precision to 0.
Yes, but what if I don't know the exact length of the number, but only thing I want to do is...
Okay, so you don't want to see the 0.
Yes, but the point, the number could be 0.15.
You want to see 78.5. Is that what you want to see? You want to see 78.5. No zeros. No trailing zeros.
Yes, but number could be different. For example, 0.55. That's
0.55, yeah.
Ama 55'te olur.
Well, I mean, the answer is I don't know. Just look up the documentation. I think I know, but I don't want to go into that one. You are going to specify more flags. Okay. Error output is available. You can send errors, the standard error. Instead of cout, use cerror. Okay. We know that. cin, we already talked about cin. No problems. I'm not going to. I mean, like scanf, but like scanf, it takes numbers from the standard input or anything from the standard output, but you don't have to specify the type. C++ already figures that out for you, the type itself. Whenever you do input-output, always prompt for input. We already know this from our C course. program style always, okay, follow the style of the, well, I mean, the word of C and C++ are similar. C programmers are similar. They behave similar to C++ programmers. That's why our convention of writing programs, our indentation, our capitalization of the variables and etc., they are very, very similar. Just know the rules and follow the rules, okay? The commands, okay, different from C maybe. We use this type of command a lot, //. If you put // somewhere, whatever you put in that line will be ignored by the compiler. That's a command for the programmer. And C-style commands are available too, okay? Identifier names, okay? We use this kind of, if you have more than one word, Turkish or English word in your variable, you capitalize the second and the third word, etc. But if you have your letters all capital, then we use a underscore character, okay? The original C++, they didn't use this notation, okay? They used this notation in 1980s, okay? At the end of 1980s, 1990s. Later, they switched to this notation, but the original functions stayed that way. So that's why in vector class, instead of pushback with a capital B, I have pushback with an underscore. So we don't have anything like that, but we have this. But for the new functions, classes, and etc., we follow this convention. Okay. Libraries are there. Yeah, we know. Okay. So far we used stdio, right? Standard IO stream for the standard library stuff, and you can include many libraries. Like for the vector you include vector. For the string you include string. For many other things you include the corresponding header, whatever the documentation says. And C++ has many libraries like C. Okay. By the way, you know that this is a preprocessor directive. Okay. C include is not a C++ keyword or C keyword. C++ doesn't understand from include. Okay. C++ only knows these keywords. Include is just for the preprocessor. Preprocessor first runs, it handles this, all the keywords that start with a sharp sign. It handles them, then it makes a new file, and that file is fed to the compiler, and the compiler compiles it. So include is not something that the C++ knows. What did we do yesterday? We did, maybe the other day, I don't remember. I think there was, yeah, where is it? Out.txt. Actually, this out.txt is a Cpp file. Remember out.txt? Yeah, this is maybe, where is my Explorer? Is Explorer here? Yep, here it is here. So out.f5, yeah, out.cpp. If I open it, this is how many lines? 28,000 lines of code. It was produced by the preprocessor, and at the end of this file, okay, see, instead of include statement, I have this 28,160 lines of code inserted by that simple line. Okay, many things, most of them are not meaningful for you. Lots of code in there too, and maybe we'll talk about why there is code in the other file. But it is what it is, right? So the preprocessor did that, and in fact, the file that it produced is another C++ file, and I can compile it out.txt. out.cpp, right? I am compiling and it compiles, right? It compiled. And I think there was an option in C++, compile it without using the preprocessor. What was the option? I forgot. -E, I think maybe -E is going to tell me that. Should I make a search? Preprocessor options. Is it -C? Let me try to find it. Okay. There is a way to disable preprocessor, and I'm trying to find that option somewhere. Yeah. Dname, you include macros, undefined, M file. Couldn't find it. Okay, let's go to web search. Disable C++ preprocessor option. Disable or enable code processor option. Can I find it easily? No, these are the options for the couldn't find it, sorry. If I had that option, I was going to disable the processor and compile it. But before doing that, I was going to put some include statement in it, and this include statement is going to give me some error messages, but I couldn't do it. So you find it. Find how to run the G++ compiler without running the preprocessor, so that you can get the error message for the include statement. Okay, so includes are like that. They are handled by the preprocessor, and they are directed to add contents of a library file to your program. So there's IO stream, the length of the IO stream is 28,000 lines long. It added to my program and I compiled it. Okay, and C++ has many libraries. Remember the namespaces? Namespaces, we didn't talk much about it. They are not that meaningful maybe, but for now, but we are going to have a discussion about namespaces. There is a complete chapter about namespaces. They are important. For now, I think this slide will be enough. The definition of namespaces is collection of name definitions. For example, you define your string class, you define your vector class, you define all of your classes inside this standard namespace, STD, namespace STD. Okay, it's called a standard namespace. To be able to use anything from standard namespace, you need to include this C++ statement using namespace STD. You are saying that whatever I am going to use, they will come from standard namespace, and I'm telling you, okay? If you don't want to say that what I am going to use, they will come from the standard namespace, but if you like to specify specific names like this one, I am going to use cin object from standard namespace, just that one. Not everything, but that one. And I'm going to use cout. Anything other than these two from standard namespace, I won't use them. Okay, that's what it means. Okay, you can have your own namespaces. Let's say you like to make a namespace for your company. Your company is ABC. Okay, you make a new namespace ABC, and you put lots of definitions inside ABC, and you can use them from that namespace. Even in your namespace ABC, you can have another cin and cout variables. They will be different from the standard cin and cout. Okay? That way, you are not restricted with, I mean, standard library is very large library. They use lots of names, and some of the names that you may like to use. Okay? So what do? You're going to make a new namespace. For example, GTU is my namespace, and inside GTU, I am defining a new variable. Its name is cout. This cout and this cout are two different couts because their namespaces are different. Okay? For now, most of the time, whenever we start writing a program, we are going to do this. We are going to tell the compiler that, okay, I am going to use namespace, whatever I use, okay. When I say string, you don't know what string is, right? It comes from the standard namespace. Just look inside the standard namespace, std, and you are going to find that string. Cin and Ct are we don't know what object is yet, but they are objects, yes. I mean, why are you surprised? I mean, 2 and 5 are variable values, right? And here, cout and 2 are variable values too. This is one is a variable, this is a constant.
So namespaces
can contain variables too, right?
and also keywords, etc.
Not keywords. Keywords are already known by the compiler. Compiler knows for keyword or if keyword. Okay? Namespaces are for definitions.
Or types like string.
Yeah. Those are definitions too. Okay, so these are the libraries and namespace. And I guess that's it for this chapter, chapter number 1. Yes? STD? STD, yeah, well, you are talking about, I didn't want to go into that detail, but yeah. STD is defined inside this header, okay? But headers are namespaces are kind of different. If you look at this IO stream, it says that I am in this header and I am defining this namespace std. Okay? So inside this IO stream header, you have the namespace std definitions.
Then we include STD also when
Inside the IO stream, you say that whatever I am defining, they will go into std. Okay?
yes, but the point that I don't understand is when we say identify IOSG, we should be able to access all the information in STD. So
well, IO stream defines the namespace std, but that doesn't mean that you are automatically using whatever you have inside the namespace std. You have to tell the compiler that I have defined the namespace std inside this header. Now I am going to use it. Well, chapter number 16 or something, when we come to that, okay, you will know. Because, I mean, inside the same header, you can define more than one namespace. And sometimes you use one of them, sometimes you use the other. Okay? Sometimes you don't use any of them.
Like if there's a line using namespace std in a library and we include it in our code.
Yeah, yeah. Well, usually you don't put using namespace stds in the headers, but if you had it that way, yeah. But that's not a good idea. Whoever includes your header doesn't have to use your all the things that you defined in that namespace, because they may want to use it this way. They may want to use it this way. Just one of them, right? Not the whole thing, just one of them. Okay, I will see you on Monday.